Girl, please.
We're already 2 weeks behind.
No.
Every day.
Y'all are starting this. I know. Wait, let's do it till Miss McGee.
I had already planned on 2 days in this section at least. Some days, some sections we'll spend 4 and 5 days on. It just depends. Here's the difference. When you come in and you're locked in and you're asking questions and we spend the whole class period and I'm like, dang, we need some more time. But if y'all aren't locked into it, there's no sense in wasting any more time on it because you're not going to get it whether I stand up here and do it or not.
All right, we're locked.
Okay. 120, what page are we on? 129. And I am used to spending a while going over homework questions. That doesn't bother me either. It's just, we can't waste. Okay, which number on? All right, what did we have? We had 1 through 6. Any questions on 1 through 6? Number 2 and number 6. All right, number 2 and 5. All right, 2, 3, 5, and 6. Number 2. These are actually quicker than what you think they're going to be. X cubed over 3. I bet the over 3 is what 3 you hear. Over 3 is just like 1/3, yes? All right, so this is just power rule. What's 3 times 1/3? 1. 3 minus 1 is minus power rule again. That's it. I've also been doing calculus a lot longer than you have. But what's 3 times 1/3? Okay, but even if you did the quotient, you'll get the same answer. It's just way more work. Derivative of the top times the bottom minus the top times derivative of the bottom over the bottom squared. This is 0. This is 9x squared over 9 minus, right, oh yeah, minus 0. So x squared for that first piece.
You can almost always use power rule. Don't make life harder than what it is.
That's okay, you're learning this. That's what this is about. Yeah. I didn't get rid of it. So this is like to the first power, right? So multiply and it becomes 1, and subtract 1, you get 0, so the x goes away. Anytime you have something like 3x, the derivative is going to be 3. 7x, the derivative is going to be 7. X over 3, what's the derivative? 1/3. If there's no power on x, it's just 1, it's just the coefficient in front. All right. 3. Same thing. Derivative of 2x. Derivative of a constant. Done. See why I said these would be quick? But it's okay. It's okay. It's only up from here. 5 and 6. Summer solving's ready to go. Y equals x. Somebody asked yesterday about the different notations. Could I just stick to the same notation? And I switch it up on you, like here I'll say y prime. And I do that because they use them interchangeably on the exam. So just know what each one of them means. All right. Again, now that you know you don't have to do difference quotient. Did you do difference quotient on these, Logan? Oh, gracious.
I was sitting there grinding them out.
So now that you know power rule, what would the first term become? X squared. Because 1/3 times 3 is 1. Take away 1 from the exponent there. How about the next one? How about the last one? Well, remember, this is that one. Is that what you're talking about? Which one are you talking about? This one? Well, because this is 1/2 x squared, so if I multiply, I get 1, and if I subtract 1, I still have an exponent of 1. It's always, your derivative always ends up 1 degree lower than what you started with. 6. Y'all, if Sullivan's making me go too fast, tell me. I know. If y'all had been this locked in yesterday, buddy, we'd be breezing through derivative rules. Girl, bye. All right. Right. You're talking about the original problem? Minus, yeah. All right, dy dx. Derivative of 1. 0, derivative of negative x. Negative 1. Derivative of x squared. Derivative of negative x cubed. Bada bing, bada boom. Still same process. Same process. We'll look at it though. Yes. Standard formula. 17. How do I move? What, 16 and 17? Oh, you didn't have 16.
No, 19.
All right, let's do.
Oh, there's no way we did only R.
Shut up.
I did every single one 1 to 30.
How long did you spend on your homework?
Or not 1 to 32. I did 1 through 6, 15 through 22, and 29.
Bro, that sucks. You'll be good at this though.
Well, he didn't do it. No, I did it.
He did it with the wrong rules. He did it the wrong way. Learning experience. Let's do this. Let's use product rule here. Did you FOIL this out?
I did. No, I didn't foil.
Okay, so you can FOIL it out and then do derivative with power rule quick like we just did. But the problem with that is, what if you make a mistake in your FOILing, right? Let's see who's quicker, me or y'all. Let's see. Let's see if you're right. Derivative of the first times the second derivative of the first times the second plus the first times derivative of the second. Now, I have seen multiple choice questions where they will say which one of these equals, and they will use the product rule, and they will give you A, B, C, D, and here are the different choices. You determine which one is the correct use of the product rule. They won't tell you that's what they're doing, yeah. Parentheses. Yeah.
I was just going from class. We imagine having all that sort of stuff.
Oh, congratulations. I'm glad. How long does crack stay in your system? 30 days? All right. I'm okay with you leaving this here for right now. If you want it in standard form, you certainly may, but that's going to involve a lot of multiplying out. Right now, I'm concerned that you know the rule. I taught you Algebra 2 and Pre-Cal. You better be able to FOIL those out. But
Look, it says odd.
17.
So you're
17. Y'all don't have to stay mad and pout the whole day. Y'all can be.
We're locked in.
That's locked in. Locked in.
Go.
All right, this is a quotient, yes. I don't know how to split this up to where I could do it any other way other than quotient. So we're going to do quotient rule.
And I did 50.
Well, you should be a pro at quotient rule now. So,
Do we have to know what rule we're using?
yes. Well, you don't have to know, but you should know which one. So right now, I would be sitting at my homework with this sheet beside me as I did my homework right now, if you need it. Oh my goodness. Derivative of the top times the bottom. This is where the order matters because subtraction is not commutative like addition is. So derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. I didn't expect you to clean this up last night because I didn't want you bogged down for hours on your homework right now. Just last night.
I didn't expect, and the answers on the paper are all to the very end, all standard.
Okay. You want to take it to the very end?
No, I'm just saying these are like, I have to.
All right, come on, let's go.
No, not gonna forget my.
What?
It's already been 30 minutes.
We're doing the same. We're doing the same lesson today. Yeah, but there's a little more to it. I'd probably leave it that way. Yeah. It depends. I'll let you know. All right, focus. We need a code word for focusing other than just.
Shark attack.
What else on your homework? 19. 19 is glorious. I love it. Now, did anybody? Yes and no. Did anyone notice anything? Somebody did. I know somebody did. Wait a second. Did you recognize it? How many of you recognize that as the factored form of a difference of 2 cubes? It was all. Dozier is really good at those factoring special patterns. Now, I'm gonna. Part of what I love about calculus is using things that make it a little bit easier. I could do quotient rule here, right? But I'm better with algebra than I am with calculus sometimes. So I think, not really, I was just saying that, but what if I did that? X cubed. Think about how you add and subtract like, you wouldn't have to do this. I wouldn't expect you to see this part. I would say, now Wyatt made a good point because he said, oh, if we do quotient rule here, we got to do product rule and quotient rule all rolled into one. And I said, yes, it's a beautiful problem, right? You would have to do that way. If you recognize the factoring, you could get it where you could just use the quotient rule. But if you also recognize the fraction, I could just do the power rule, right? 1 minus x to the negative 3. Nice, because now, and this is a good place to talk about that negative exponent rule that y'all talked about. So I haven't even done any calculus yet. Y'all see that? I've done 0 calculus at this point. I've done algebra 2 and algebra 1. Right? Splitting up a fraction, that might even be 8th grade. I don't know. With variables, I guess we'll give it algebra 1. But the point of the matter is I haven't done any calculus yet. I've just used my prior knowledge to write it a simpler way. Because now to take the derivative, yeah. So think about adding and subtracting fractions, right? If I had x cubed over x cubed minus 1 over x cubed, because they have the same denominator, I would just do x cubed minus 1 over x cubed, right? I just split it up. I went the backwards of that. And so this over itself is 1. I changed this to the negative exponent because I'm fixing to apply the power rule. I'm not sure what you're asking, to be honest. Let me do it in just a minute, though. Let me do it in just a minute. Oh, I haven't found the derivative yet. Yes, I haven't found the derivative yet. This is still the same problem. I haven't done any calculus yet whatsoever. Yeah. I haven't power ruled yet. No, I haven't found a derivative. Right now, all I've done is written it a different way. Now take the derivative of that. If this is y, then the derivative of y, what's the derivative of 1? 0. Don't worry about it. Multiply, right? Negative 3, positive 3, x, subtract 1. I could leave it like that, or I could write it that way. Either one would be acceptable.
It was a lot easier than you made it.
I didn't even make it up for it. I just left it after I did the quotient.
Did you do the quotient with an embedded product rule, or did you FOIL out the top and do okay.
Is it right?
Yeah. The ones like the first one is the first step, the second one is the middle step, the third. All right, 21. I don't have any magic tricks for 21. 21, we just have to go with it. All right, to find the derivative here, we're going to have to do quotient, yes? Derivative of power. Oh. I want y'all, this is good conversation we're having here. This is what I expect from y'all when we're discussing the problems and the ways to do it. So don't think we're yeah.
I put them on there.
You know what? I'm fixing to show you, and you're gonna whenever you see that one, you're gonna go, oh my gosh. All right, derivative of the top. 2x times the bottom. Again, if you need your sheet, use your sheet, right? This is the quotient rule. Derivative of the top times the bottom minus the top times derivative of the bottom. There you go. All over squared. I wouldn't FOIL the bottom. When you are in completely factored form, remember how in pre-cal we talked about completely factored form means every plus or minus is enclosed inside a parenthesis? And I've got this that's sitting out here. I would work on the top maybe to see if it cleaned up a little bit. I wouldn't bother the bottom. So I would have 2x minus 2x to the fourth plus 3x to the fourth over that factored bottom, which gives you what? But there's nothing to factor it with in the bottom, so it doesn't do much good. Yeah. Derivative of the top. So it's always, if you've got u over v, this is top, this is bottom. The derivative is, you take the derivative of the top and multiply it by the bottom, minus, you take the top as is and multiply it by the derivative of the bottom, and then you take the bottom squared. So this is derivative of the top times the bottom minus the top times derivative of the bottom all over bottom squared.
All right. I hope you're feeling a little bit better as we go.
Yes. What? 23. What C? Suppose u and v are functions of x that are differentiable at x equals 0, and u of 0 equals 5. This is a typical multiple choice problem.
This was not on the. It was not on the canvas assignment. It was on the video. I wrote it down. I have a picture of.
Don't trust Canvas. It says comma. You didn't take a picture after I finished writing. Did you do it, Wyatt?
He called me.
Did you?
He's lying. He called me.
You gotta give me credit. I did all the even.
I don't think you understand. Get with somebody who didn't get full credit on their homework and have them show you.
I like it.
If you're confused that you might not get full credit on it. All right. He's worried that he's not going to get full credit because he missed one problem on the homework. It's not, he didn't do one of the problems. But he did all instead of odds on one, and he was saying, and I was saying, no, this on his homework, I haven't graded it yet. And he was thinking, and I said, because you missed one problem? And that's what I was saying. Right, yeah. No, Wyatt. All right. Part A says find the derivative of u times v. What, you skipped one? You did what was on Canvas? All right, so it's asking me to find the derivative. I can't just plug in the way it is, and it's telling me when x equals what, 0? Did I copy these right? 5, -3, -1, and 2. All right, so this is going to be derivative of the first times the second plus the first times derivative of the second, but they're all occurring at that particular value. So that's what they've given me, right? So derivative of u would be -3, v of 0 is -1, u is 5, derivative of v is 2. Oh, because that's 3, not 6. There it is. What? No, that's not hard. So then part B asked me for the quotient. This was literally just testing your quotient and product rules and things like that. And your reading skills. Derivative of the top times the bottom minus the top times derivative of the bottom, all over bottom squared. And then I just plug and chug. -3 times -1. U is 5. V prime is 2 over V is -1 squared. There's your -1 squared, Dozier. 3 minus 10. Positive 3 minus 10. -7. Do y'all need me to keep going through these? Yeah. V. What you got?
Oh.
C also? Yes. All right, so C is the derivative of V over U. Derivative of the top times the bottom minus the top times derivative of the bottom, all over bottom squared. And so B prime is 2, U is 5, V is 2, U prime is -3 over U is 5 squared. 10 plus 15 over 25. 25 over 25 is 10. Did I mess up? Where did I mess up? Oh, V. -1. Sorry. So that's 10 plus 3. that positive one or negative one? Minus over 25. 7 over 25. And then the last part there, 7v minus 2u. Sorry, I want to be able to reference this. So this would be, if you do the derivative of 7v, I can pull that 7 out in front and do this, yes? That's that or that coefficient rule. So what I'm really doing is 7 times v prime minus 2 times v prime. V prime is 2, u prime is negative 3. 14 plus 6, 20. What you got? Probably on the quiz, yeah, I'll probably change it. We'll probably use it for a little while. Maybe not on the test. I'll let you know. 31? Let me tell you this about these kind of problems. I think all of you had problems with this last section. Can you write that as an exponent?
Yes.
How? If y is the square root of x, what's the derivative of y? 1/2 x to the negative 1/2, or 1 over 2 root x. This is the same thing as x to the 1/2, and I just did power rule. What's 1/2 minus 1? What's a negative exponent do? Puts it at the bottom. That's how you find the derivative of a radical. 1/2 minus 1 is negative 1/2. If you have 50 cents and somebody says, give me $1, you're short how much? 50 cents, half a dollar. This isn't 31. I was just sidetracking here a minute to answer this so that whenever I go over 31, it'll make a little more sense. Either way is acceptable. I tend to leave it there. All of a sudden, negative exponents aren't bad anymore. Radicals in the bottom aren't bad anymore. Which one did y'all say? 31? 31's kind of gross. Square root of x minus 1 over square root of x plus 1. I might just leave it. I might just leave it and do quotient rule. That's going to be more work on me, I think, if I try to. Just because whenever I look at it, these, whenever I do the derivative of these, that's just 0. So I think quotient will be easier. Let's do derivative of the top. What's the derivative of the top? Half x negative 1/2 times the bottom. And sometimes I'll go ahead and do this and change that to an exponent. It makes it a little easier as I work. Bless you. I didn't take the derivative of it. It's derivative of the top times the bottom minus the top times derivative of the bottom. The derivative of the bottom is the same thing. Is what matters. Good. Can't cancel yet, yeah. No, you don't have to. I'd leave the bottom there a bit. I might try to work this top a little bit. Negative 1/2 plus 1/2. 0. right? I'm writing it so you see, but it's not actually there. This is just a half. Plus 1/2 x to the negative 1/2. Minus, again, this is just going to be a half, right? Minus and then we're just bogged down in the algebra of it. All right, this is not here, this is not here.
Wait, all the pockets cancel. Minus.
But minus a negative is plus a positive. So I get a whole x to the negative 1/2 over. I would probably stop there. Or you could write it as 1 over, and this could move down to the bottom and be square root of x times square root of x 1 squared. You can, I mean, there's no rule on how far you have to go with that. I mean, you could, depending on what's being asked of you. If you're in a multiple choice situation, you're going to have to work it all the way down until your answer matches the way their answer works. But. All right. It's more of the same. More of the same. Continuation from yesterday. This is number 33. These are kind of going to model the type stuff you do. I'm going to try to do this periodically. No. We're moving on. Yeah. No new one. The same. I mean, there's a couple things I need to tell you about from this lesson, but yeah. What you writing paper about? Calculus? Take the third derivative of this function. In other words, consecutively take derivatives until you get to the third time. So I want you to find this. Is that possible?
Yeah.
Find the first 3 derivatives of the function. Find derivative, then find the derivative of that, then find the derivative of that. I stopped at 3 because I didn't want to. I said what? Is there what? Oh gosh, yes. We're fixing to get the PVA. That's probably 25% of calculus is PVA. Yeah. All right, so do the first derivative. What do you get? Measure these. Okay. Okay. Go. Darcy wants to try it. Then find the derivative of the derivative. Right. Can I do the first one? What's the derivative of the first one? I hope you're getting a lot faster with the power rule now. Okay. Now if I do the second derivative, I'm just going to put a little dash mark and say this is the second derivative of y. So exactly, yes. 12x to the second. I'm using this equation to find the derivative. It's just doing it over and over. So if I ask you to find a third derivative, all I'm really asking you to do like this. I told you once we got into the derivative rules. I think y'all, I don't know what happened yesterday. Coach Mac, because she brought me another one and my dog ate it.
What we got?
You'll never guess. Okay. Yeah. He only likes to eat Dozier.
Today.
Here's where we get into the application stuff that y'all hate. Find an equation of the line perpendicular to the tangent line. So what am I asking you for? The normal line. Find the equation of the line perpendicular to the tangent line of the curve at the point 2,3. Mark, set, go.
Whoa. Say it again.
Find an equation of the tan line at the point 2,3. Actually, find an equation that is perpendicular to the tan line at the point 2,3. If you want to look in your book, I'm literally reading it from your book. It's number 37. Mark, that go. Mark, that go. Okay, so some of you are like, I don't have it. And some of you are like frantically writing because you're going, oh yeah, oh yeah. Oh, that's what I meant. What do I need to write the equation of the line? A point and a slope. All the time. A point and a slope. A point and a slope. I have a point. The only thing I'm missing is a slope. If I take the derivative, what am I finding? Slope of what? Somebody said it, the tan line, right? This is the slope of the tan line. Yes? But I want the slope of the tan line at 2. Derivative of y. We just plug in. So this is what we were doing back before whenever we were doing the difference quotient, but we were filling in the difference quotient. We were putting a 2 in for x. So we were literally going, the limit is h goes to 0 of f of 2 plus h minus f of 2 over h. The only difference is now I can shortcut it with my power rule. The same thing. So this would be 3 times 2 squared minus 3. 3 times 4 is 12. 12 minus 3 is 9. Yes? What is 9? Tell me in words what 9 is. The slope of the tangent line, keep going, at the point 2, 3, right? This is a cubic at this point 2, 3. If this is 2, 3, the slope of this line is 9. Okay? That's not what we're finding. I asked you for an equation of the line perpendicular to the tan line at that point. Close. The slope I'm looking for, which is perpendicular to the tan line, is negative 1 over 9. So now m of the perpendicular tangent. Slope of the line is perpendicular to the tangent. So, or you could say the slope of the normal line, because that is exactly the same thing. Yes? Different? Huh? You can leave it in point slope form. That's what I would do.
But if it wasn't perpendicular, you would just do.
The answer is the equation for the line. So y minus 3 equals that new slope I have, x minus 2. I usually bring over the minus 3. It's good form just to be solved for y. You don't have to simplify any of this on the other side, but just to have y by itself, because in general an equation of a line is y equals.
I started doing it like, as a.
It is a different slope. You just did way more work than that. You're not wrong.
Using this same problem, find where the tangent is horizontal. Where or do I have a horizontal tangent anywhere on this graph? What happens to the horizontal tangent? Horizontal, not vertical. Not y. What's 0? Not x, the slope. The slope of what? The slope of the tan line is 0 at a horizontal tangent. That's a big concept, okay? If you don't have that written somewhere in your notes, write it down, highlight, do something. The slope of the tangent line at 0 is a horizontal tangent. Or when the slope is 0 of the tan line, that's a horizontal tangent. So this is when so if I take the equation for the slope, yes, what's the equation for the slope? Remember, slope of tan, right here, we have it written. Slope of the tangent is 3x squared minus 3. Where does that equal 0? That's half the answer. There you go. I have 2 horizontal tangents on this graph at positive 1 and negative 1. What if I asked you, where is the slope of the tan line? Because this is what you'll have to do in number 38. Taking this same equation, all you have is what's in green. Where is the slope of the tan line for?
What number was it?
What's in green there? Just that equation? This? Y'all, that is definitely like sea green.
That's about.
Okay. Yes, what? Yes. Where is the slope of the tan line equal to 4?
Where?
If instead of 0, right. Do y'all understand what I'm saying? Let me read this question to you. Find the tangents to the curve y equals whatever your equation is. This is number 38 on your homework. It's a different equation, but same concept. Find the tangents to the curve y equals blah at the points where the slope is 4. So what do I do? That's the problem, but not the y problem. Which problem? The derivative problem, right? I can find, you will if you set equal to 4. If you set 3x squared minus 3 equal to 4, right? You will, but that's okay. There's nothing wrong with that. 120, 130. All right. Yeah. It's this. Nope. Ah. Ah. Oh my gosh. For what? No, this is my. Pre-cal, I think it's the hardest for sure. Your grade right now is that because you thought that you could come in here and do the same thing that you did in the other classes. No, it is. The difference is this is new stuff. What's today? Okay, Liza, it should be there. Okay. Here's where it gets good. Y'all ready? You've got two problems that do the same thing, 46 and 48. I'm going to do one of them with you. I'll do 46. The cylinder one. No, chemistry took calculus.
I mean, without chemistry, you kind of have nothing.
You couldn't do chemistry without calculus. Math is definitely older. You could do, okay, let me ask you this.
Chemistry's from the start time.
Can you do calculus without chemistry? Yes, can you do chemistry without calculus?
Yeah.
You don't know that because you don't know calculus. All right.
We did chemistry with only algebra 1. So.
All right, look. A, B, N, and R are constants. Find, you don't even have to know what this is. Cylinder pressure, gas in a cylinder. Why don't y'all tell me what this is? Y'all know it. What does that tell you? Pressure. If gas in a cylinder is maintained at a constant temperature T, the pressure P is related to the volume V of, we don't even have to know all that. Okay. Find, find VPV. All right, listen what it's asking. Listen what it's asking. This is very intimidating. Find the derivative of P with respect to V. Remember, we've been doing dy dx, right? We're doing y with respect to x. X is my variable that I am doing the power rule to, and the quotient rule to, and everything else. So now V is that token, or that variable.
So we find the
All right, so what did you ask? You're finding dP dV, the derivative of P with respect to V. Okay. All right. This is like my X and this is like my Y. If this was Y equals this and this is an X and this is an X. Find the derivative, okay? Now, P is like your Y, V is like your X, okay? A, B, N, and R are all constants. I'm going to circle those so you see. There you go. You're exactly right. That's what Sunny was saying earlier. Constant, 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 constant. It said constant temperature. N and B. All of those are constants. But it said in the beginning of the problem at a constant temperature of all right, one more time. Listen, listen. At a constant temperature T. So T has to be a constant. It's defined in the first part of the problem. Now, if I find the derivative, watch what happens. This is so neat. Quotient rule. Yes? Quotient rule? Derivative of the top. What's the derivative of a constant? 0. Derivative of the top times the bottom minus the top times derivative of the bottom. What's the derivative of the bottom? No, no. 1. If this was an x, what's the derivative of x? 1. Doesn't matter. I'm just showing you. I'm just showing every single step. Now I've got a second fraction there. Derivative of the top. Second fraction now. Derivative of the top times the bottom minus the top times derivative of the bottom. 2v. Over bottom squared. Yeah? I know y'all feel like we're working for a very long time, and we are. These are actually your homework problems we're going through. All right, so let's go through. That's 0. That's 0. Bless you. I've got negative nRT over minus, actually plus minus the negative. Yep. 1 minus 0 is 1.
I love it canceled out.
What? That's it. Done. It was not as hard as it looks because I just keep carrying my constants, and every time I take a derivative of a constant, it's 0. Okay? That's the answer. Yeah. Yeah. The what value? Derivatives of the rate of change. So you're looking at how the pressure changes with respect to the volume. As the volume changes, how does the pressure change? So no. Yeah. That's the one you're actually taking the derivative of. That's the one you're looking at. We'll get to some. That's whenever we get into implicit differentiation, where we're going to have multiple variables, and we only take with respect to one, and I'll show you. Yeah. Okay, come grab one out of my desk drawer. All right.
Wait, you never told me about
Brussels sprout. Here's what I want you to do. Now, part of using all your time in class is you've got 18 minutes, so get started on this. Here's what I want you to do. First drawer on the right, yeah.
All right, what are the homework numbers tonight?
Logan Freeman, write this down.
Oh, Logan, we don't have to do it.
24, 38, 47, this one, that's super quick. That's super quick. 55 through 58 are multiple choice. Show your work. Do not just put answers on those. And then the big part of tonight. On page 132, there are 4 practice AP questions. 3 are multiple choice, but they are actually from AP exams and stuff. And then the 4th one is a free response. Sometimes you'll struggle on those, and sometimes you'll breeze right through them depending on how well you've grasped the material. But that's a good check for us to see about halfway through the section